Okay, in the last class we had discussed about the physical properties of metals and non-metals, right? Okay, so you all tell me what are the physical properties of metals in the last class that we discussed. One by one can tell me what are the physical properties that we discussed in the last class of metals. Nishaya, so many properties were discussed in the last class. Can you tell one property?
Ductility.
Yeah. So metals are ductile. Okay. What is the meaning of ductility?
They can be stretched into wires.
Okay. Yes, Janvi. Next property.
They're lustrous.
All right. All right. So, and Sakshi, any property of metals that you can say?
I don't remember any.
Okay. There were a lot of properties that were discussed. Anyways, Shriram, can you tell me one property of metals?
Malleability.
Okay. What do you mean by malleability?
They can be beaten into sheets.
Yes. Yes. Very good. Very good. Okay. So metals are malleable. They're ductile. They're
Ma'am, this
this is your voice and means I don't there's something.
I can hear echo in the voice. I don't know why.
Yeah, now it's okay. Now it's fine. Yeah. Now am I audible to everyone?
yeah.
Okay. So in the last class, we discussed that metals are malleable, they're ductile, they're lustrous. Okay, they are sonorous. What do you mean by sonorous? What is the meaning of sonorous?
Can I say?
Any idea? Yes. What is the meaning of sonorous property of metals? Does anyone remember? Okay, sonorous property means they have a different kind of sound. That's why they are used to make bells. Okay, they used to make the temple bells, school bells. So different kinds of musical instruments are also made out of metals because they are sonorous and they're also very hard. Okay, that's why these infrastructures and all like construction parts, they all made up of metals. So these are some of the properties that that means the physical properties of metals. Okay, in the last class we already discussed that materials are of two types and they are metals and non-metals. Okay, next slide. Yeah. So physical properties are the properties that can be sensed via that can be detected by our sense organs. Okay, that we can sense. It can be what it can be smell. It can be the feel of the material. It can be the sound of the material. So all these can come under physical properties, and chemical properties are the properties that becomes evident only after chemical reaction. You can observe these properties only after chemical reaction. Okay. Next slide. All right. So first of all, we'll discuss what happens when metals react with oxygen. Okay. When any metal reacts with oxygen, they form a metal oxide. Okay, metal oxides are formed. For example, you can see in the first case, that is magnesium. When magnesium burns in the presence of oxygen, magnesium oxide is formed. All right, and because of the formation of the magnesium oxide, there's a white colored flame while burning uh, the magnesium ribbon. All right, so when magnesium reacts with oxygen, magnesium oxide is formed. That is an oxide of magnesium. All right, now what happens when copper reacts with oxygen? Okay, when copper reacts with oxygen, the oxide of copper, which is called cupric oxide, is formed. All right, you can see the picture. So this is the oxide of copper. Copper does not look like that, but when copper reacts with oxygen, cupric oxide is formed. All of you can note down the reactions. Okay? You all can note down the chemical reactions. All right. Now, what is the third reaction? Like the third example is of iron. When iron reacts with oxygen, ferric oxide, we also call ferric oxide as rust in simple terms. Okay, so when iron reacts with oxygen in the presence of moisture, okay, what happens? Rust is formed. Rust is ferric oxide. All right, and when aluminium reacts with oxygen, aluminium oxide is formed. So whenever a metal reacts with oxygen, the metal oxides are formed. Okay, all right, next slide. Okay, now we'll see, we'll carry out an experiment for that. Okay, this is magnesium ribbon. Just give me a minute.
So while ma'am is, preparing for the experiment, let me tell you a few things about this. Now, magnesium is something which is widely used in preparation of firecrackers. Okay, in the picture on the slide, you all saw that when magnesium is burnt, when it is reacted with oxygen, it produces a bright light. Okay, so we also call this reaction as an exothermic reaction. Okay, exothermic reaction means some kind of energy is given out while this reaction takes place. Okay, now here when you'll observe the reaction that Nicola ma'am is going to do right now, you will see that while magnesium burns, it burns with a bright flame. Okay, you might not be able to gauge the intensity of light with which it is burning because you're seeing it through a video. But when you are doing the reaction for yourself, when you're doing it live, you'll see that the flame is so bright that if you look at the flame, directly, if you look at the flame, for a moment, you get the, kind of blackout of your eyes. It is so bright. Okay, so generally when you are performing this reaction with your hands, you are not supposed to look at the flame when you are doing this reaction. Okay, and second most important thing that you need to remember is, along with light energy, a lot of heat energy is also produced when this reaction takes place. Okay, so we should not drop the burning magnesium ribbon on a glass plate or any glass container, because the heat is so immense that the glass tends to crack. Okay, these are certain. So probably we are not sure. So today, none of y'all were instructed to gather any material. But if suppose you have any of these materials which we are using for the reaction, you can perform it after the class. So you have to take care of two things. One, you should not look at it because the light is so bright. And second, while the magnesium is burning, it should be held very tight in using the tongs. You should not drop the burning magnesium on the floor or on the, on a glass petri dish or a watch glass, because that might break the glass. Okay, is that understood?
Yes.
Yeah.
Okay. So this reaction is called an oxidation reaction, or it is also known as combustion because it is burning in the presence of oxygen, or it is also known as an exothermic reaction. Let's observe the reaction now.
Yeah. So can you all see the magnesium ribbon, everyone?
Yes.
Yeah.
Yes.
Okay.
You might have to use a candle or a spirit lamp. It won't burn very fast using the matchbox. So you burn the magnesium ribbon using a candle or a spirit lamp.
Yeah.
So in this reaction, what we are going to do is we are going to burn the magnesium ribbon and we are going to collect the ash, because we are going to use this ash which is produced during the reaction for carrying out another experiment after this.
Okay.
So can you see how bright it is?
Yeah.
So imagine if you're seeing it, with direct eyes instead of a video, it is very, very bright. Okay. So high in height, light and high in heat. So it is giving away two types of energy, light energy and heat energy. Can you see the white ash that is formed? Oops. Okay. So we have collected the ash in a petri dish. Okay.
Yeah.
So this is how metal, so magnesium is a metal, and this is how metals react with oxygen. That means when we burn metal, a reaction with oxygen takes place. Now let's see what ma'am has to show us after this.
Okay. Can you see the ash in the petri dish? Everyone, can you all see it?
Yes.
Okay. So we'll make it into a powdery form. Okay.
So ma'am is dissolving the ash with water. So we had magnesium, we burnt it, we got magnesium oxide. Now we are mixing magnesium oxide with water to make magnesium hydroxide. Okay. And then we will use a litmus paper to test the product which is formed, whether it's an acid or a base. Do you all know how litmus paper works?
Yes, I do.
Okay, can you explain it?
So there's a strip. It has colors on it, and
How many colors?
it
Um, okay, go ahead. Go ahead with your explanation.
it has some colors, and the color, you just dip a strip inside the solution, inside a
Hmm.
solution, and the color, you match the color with the color on the strip, the colored strip. You match it,
Okay.
then you say is if it's acid or a base.
Yeah.
It
So what you're talking about, Nishreya, is not a litmus paper. You're talking about a pH paper. Okay.
yes.
Yeah. So litmus paper comes in two colors, red and blue.
Hmm.
Okay. So what happens when you dip a litmus paper in acid, and what happens when a litmus paper is dipped in base? Okay. So there is a thumb rule which you all need to remember, is that whenever any litmus paper, either red or blue, whenever it is dipped in an acid, the end result will be red color. So if red is dipped in acid, red will remain red. If blue is dipped in acid, the blue will turn into red. So the end result for acid will always be red, and the end result for base will always be blue. So B for base and B for blue, that's how you can remember. And red color for acid, because acid is dangerous. So this is something that you all can remember for yourselves. Okay.
All right. So we got magnesium oxide. Okay. We'll mix a little bit of water, and then we'll test it with red litmus paper. Okay. So can you all see the litmus paper?
Yeah.
Okay. So now we'll test it with red litmus paper and we'll see what happens. We can just put it inside the thing and we'll, after some time, remove it.
Um, Ma'am, can you show it near the camera?
Is it visible?
Yes.
Yes. So what is happening to the red litmus paper?
Yeah, I'll show it. I'm just taking,
Yeah.
let it change.
So I'm just asking the students. So what do you observe?
All right. See, what is the color? Tell me.
Blue.
What does that mean? The red litmus turned into blue. What does that mean?
Yes.
It's a
Yes.
base.
Base.
Okay. So the solution is basic. All right. So the red litmus turned into blue color. So metallic oxides are basic in nature. Okay. That means that metallic oxides are basic in nature. All right. You all can even try it with rust. You all can dissolve, you all can suspend rust in water, and you all can, like it can be tried with the litmus paper, or you all can also try it with turmeric paper. Have you ever prepared turmeric paper? Turmeric is also an indicator. Have you all prepared turmeric paper anytime?
No.
Okay. Let us try it with turmeric paper once also. Okay. So this is turmeric paper. All right. You all can prepare it at home easily. You all just have to prepare uh, a solution of turmeric, and you'll have to put it on the paper and allow it to dry. Let's see what happens to the turmeric paper. All right. We'll leave it as such for some time. You all saw what was the color of the turmeric paper?
Yellow.
Yeah, it was yellow.
It was? What is the color of the turmeric paper?
Yellow.
Turmeric.
Okay. Can you see any change in color?
I guess it's orange.
What is that? Nisha, what did you say?
It's a bit dark. More towards orange.
Yeah. If you suspend it for a little longer time, it will become red, okay? That means when the turmeric paper changes into red color, that means it's a base. If it's an acid, it will remain yellow in color. If it's a base, it will turn into red color. Have you all seen that if you all have dropped some curry or something on your clothes and you all wash it with soap, then that portion becomes red in color? Have you all ever observed that if you all drop some food, maybe some type of curry or something on your clothes, and you all try to wash it out with soap, it will become red in color. Have you all ever observed that?
It's not happened with me.
Okay. If ever you'll drop any curry or something or a stain comes, okay, and if you'll try to wash it out with soap, then it will become red in color, okay, because the soap is basic in nature, okay, and when the base reacts with turmeric, okay, it will change its color to red. All right, we'll move on to the next slide. Okay, what happens to non-metals with oxygen? Very few non-metals react with oxygen, okay? Like we know that carbon reacts with oxygen to form carbon dioxide, okay? In the same way, sulfur also reacts with oxygen to form sulfur dioxide. Not all non-metals react with oxygen. A very few non-metals will react with oxygen to form the non-metallic oxides, okay? All of them do not react with oxygen. All right? So in case of metals, all the metals react with oxygen to form metallic oxides. And what is the nature of the metallic oxides? Is it acidic or basic in nature? What did you all observe? What happened to the litmus paper?
It's basic in nature.
Yeah. So metallic oxides are basic in nature. And non-metals, when they react with oxygen, their oxides are acidic in nature. Okay? Their oxides are acidic in nature. So it's vice versa. If like metallic oxides are basic in nature, whereas non-metallic oxides are acidic in nature. Is that clear to everyone?
Yeah.
Okay, we'll move on to the next slide now. Okay, yeah, we'll be seeing a video for this.
Yeah, so we will put the video towards the end of the session after we finish the complete explanation.
All right. All right, next slide. Okay, what will happen when metals react with acids? Okay, if a metal reacts with an acid, a salt is formed and hydrogen gas is evolved out during the reaction. Okay, so whenever a metal will react with an acid, a salt will be formed and hydrogen gas will be evolved out during the process. Okay, there are some examples. the most common example we can say of common salt. Okay, how common salt is formed? When sodium reacts with an acid called hydrochloric acid, sodium chloride is formed. Okay, and hydrogen gas. Can you all see how the reaction has taken place? Na plus HCl. So Na and the Cl combines together to form a salt, that is sodium chloride. Okay, and the hydrogen gets separated out. Hydrogen gases evolved out during this process. In the same way, look at the second reaction, that is calcium plus sulfuric acid gives calcium sulfate plus hydrogen. So what happens to calcium? Calcium Ca, okay, that reacts with SO4 to form calcium sulfate, and hydrogen gases evolved out. Are you all able to know how the reaction is taking place? In the third case, what is happening? Zn, that is zinc, combines with Cl, okay, and it forms zinc chloride, and hydrogen gases evolved. So one common thing that you all see in all the reactions is that hydrogen gas is evolved out in all the reactions, and a salt is produced when a metal reacts with an acid. So these two things you all must remember, that when a metal reacts with an acid, a salt is formed with the evolution of hydrogen gas. Okay?
Okay.
Yeah. Okay, we can move on to the next slide. Okay. So reaction of metals and non-metals with acids. Okay, this is aluminum foil. Okay, yeah, we can test it. Copper wire, magnesium ribbon, and graphite, okay, which is from the lead of a pencil. So first of all, we will test with, we have to test a metal with acid. Okay, so we will use an acid called hydrochloric acid, dilute hydrochloric acid. It is the dilute form of hydrochloric acid. Okay, and we'll use metal. So what is the metal that we are going to use is, see, I've taken bits of can you all see it? Aluminium foil.
Yeah.
Is it visible to everyone? Okay. So what we'll do is, first of all, let me. Okay. So first of all, we can add little bit of aluminium foil to a test tube. Okay, just give me a minute. Okay. So first of all, we'll put bits of aluminium foil into the test tube. Can you all see it?
Yeah.
Okay. So now you can add hydrochloric acid.
Nicola ma'am,
Yeah.
can you hold the test tube very close to the camera because there's a lot of light, so they won't be able to see the hydrogen bubbles otherwise. There's a lot of light.
Is it visible?
It is visible, but the gas won't be visible. Like, the background is white, that's why.
Okay.
Ma'am, can you hold something at the back of the test tube? Any other colored thing? It's all white.
Gas hasn't evolved up till now.
No, but then we can't see the test tube also because of the white apron. If you can hold something.
Is it better now?
No, we can't see it at all. Yeah, much better.
Slow reaction. Let us try. I don't think any reaction is taking place.
Do we have iron filings?
Yeah, iron fillings we have.
Can we try with iron filings because they are in the raw form? So iron filings with HCl.
There is something wrong with the HCl, not the aluminium foil.
Okay. Do you have any
Yeah.
other acid?
No. Let me check out.
So at times, if the acid is like, old, now this acid is something that we used in the lab 4 or 5 months back, okay? And it's been 4 or 5 months that we have not used this acid. So, at times, due to the time duration also, the chemicals stop functioning. It may be due to the effect of light on it. All the chemicals are light sensitive. So if if they're exposed to light, you might have seen, many of the chemicals liquid chemicals that we stored were in brown color bottles in the lab. That's because they have sensitivity towards light. So if they are kind of exposed to light, they lose their properties. So this could be one of the reasons. We'll still let Nicola ma'am check it. Janvi, you have a kit with you, right?
Yeah.
Do you have HCl? Have you, you must be having the supplies then?
Yeah, I do have it.
Okay. And you have the iron filings and everything?
Yes.
Can you gather it?
Yeah, it'll
Give.
just take a second.
Yes, yes.
What do I need?
You will need hydrochloric acid, and you will need any metal. Like if you have iron filings, you can use them. If you have aluminum filings, or if you have zinc filings inside, you can use zinc
Yeah,
filings.
I have iron filings.
Yeah, you can try it with iron or zinc.
And I'll be needing a test tube.
Yeah.
Second,
I'm
I'm just
also trying it with iron filings once more. Let's try. Uh, let's see if any reaction occurs.
I think shaking will not be required. It will happen automatically. Is your aluminium reacting, or it is still not giving out any bubbles?
No, it did not give out any bubbles, so it is not reacting. I don't know.
Okay.
I'm just going
There's
in
no
the
reaction.
Okay. Janvi, if possible, use zinc instead of iron.
Okay, I'll see if I have it.
Nicola ma'am, do we have zinc?
No, we don't have zinc. There's no reaction taking place.
And that's okay. We can show them the reaction.
I don't have zinc.
You don't have zinc? Okay. What other metals do you have, Janvi?
I just have iron filings, some copper wires.
Try it with copper then.
Okay.
Nicola ma'am, no, it won't work. It's an acid.
Yeah.
It won't work. No problem. The acid would have
Yes.
lost its properties, maybe because of that. But with sodium hydroxide, it worked, right?
Yeah, that's what I'm saying. There's something wrong with the acid.
Okay, no problem. So we will let Janvi try for the acid.
Yeah. No, it does not work.
No problem. Yeah. Janvi is going to use copper, right?
I have copper wire.
Okay, see if it works. Yeah, copper wire can be used for HCl. Just put a few small pieces of it.
Pieces of copper wire.
Yeah, in the test tube, and then add hydrochloric acid.
We have to cut this.
You can
Just
use
a
a
second.
scissor.
Yeah, I'm just going to get it. Would this be enough?
Yeah. Can you put 2 pieces of that size?
Okay. Now I have to put the hydrochloric acid.
Yeah. Be careful with it.
How much?
So as to dip the copper wire. It should be dipped in the HCl.
Okay. Wait. This one's empty. I'll just use the other one. What happened to all the hydrochloric acid?
What happened to it?
I don't know. It's just empty. I didn't even use it.
Yeah, that's what. So, with time, it's an old kit.
It's about 1 year old. Yeah.
Yeah, so no wonder. No problem.
Yeah.
No problem. Let be. We'll move ahead. What we'll do is we'll show it when we have a fresh acid with us. Once the lockdown opens, we can procure the acid and we'll be showing it to you then. Okay. And till then, we'll be showing you a video in the end to explain how it works. Okay. Let's move.
Okay. So when metals, okay, they react with bases, then what happens? First of all, salt and hydrogen is formed. Okay, when metals they react with bases. Now, then salt is formed as well as hydrogen is formed. We can see that in the next experiment. Okay, what happens is, for example, if sodium is a metal and it reacts with a base that is sodium hydroxide. Okay, so then sodium aluminate and hydrogen gas is formed. All the metals don't react with bases. Only a very few metals they react with bases. Okay. Another example is zinc. When zinc reacts with sodium hydroxide, what happens? Sodium zincate and hydrogen gases evolved out during the process. So the same thing happens with when metals react with acids and bases, what is the common thing? That hydrogen gas is evolved in both the cases. Okay. And in case of when metals react with the bases, then a salt is formed. Okay. In that case, also salt was formed. In the previous one, we can see the experiment. Okay. First of all, we'll prepare a solution for sodium hydroxide. So this is sodium hydroxide. Okay. Just give me a second.
Janvi, you can also try it simultaneously. If you have sodium hydroxide with you,
Okay, I'll check.
that will be in a solid form.
Yeah, I do have sodium hydroxide.
Sodium hydroxide is a very strong base, so don't touch it with your hands. Just put it from the bottle to the test tube directly.
Okay.
Okay, see how ma'am is doing it. And make a concentrated solution of sodium hydroxide.
So you need sodium hydroxide. And you can add some pellets of sodium hydroxide, and then you can add a little bit of water, not much. Don't make it very dilute. Is it visible?
Yes.
Yeah.
Okay.
Do you have aluminum foil pieces, Janvi?
I don't have, but I think I have aluminum foil. I could cut it.
So you bring aluminum foil and you can make small pieces out of it.
Okay.
Okay. Yeah.
So we add little bit of water. Okay. Okay. So now we can add aluminum bits of aluminum foil. Can you all see it? Wait, I'll just adjust. Is it visible to everyone?
Yes.
Okay. Now, we'll add sodium hydroxide. Okay.
Can you all see the gas bubbles formed?
Yes.
Can you see it?
Yes.
Can you see the gas? Everyone?
Ma'am, can you hold it close to the camera once?
I have to, okay. So now we'll see which is what gas is this, okay? Oh, the reaction is
Over.
yeah. Okay, we can try it once more, okay?
Okay, so is Janvi ready?
I'll just get the foil.
Okay.
See again. I think I should. Okay. Now I've added aluminium foil. Okay. Now I'm going to add sodium hydroxide. Can you? Did you hear a sound?
Yeah.
That's called a pop sound. Okay. That is because of the evolution of hydrogen gas. That sound detects that hydrogen gas is being evolved out. All right.
Janvi, do you want to try it out? You ready?
Yeah. So, okay. I'll just get the test tubes.
You need not burn. I mean, don't use a matchstick. Just show the evolution of gas.
Okay.
Okay, you prepare it. We'll continue the explanation. Once you're ready, you just stop us. Okay? Moving back to the presentation.
Okay. So when metals, we already learned about what happens when metals react with acids and what happens when metals react with oxygen, right? Now, what will happen when metals react with water? So when metals react with water, metal hydroxides are formed. Okay? Metal oxides or hydroxides may be formed. Take the first example, that is when sodium reacts with water, what happens? Sodium hydroxide is formed. We just saw sodium hydroxide, which we tested. This is Sodium hydroxide. I put the pellets, right? You all saw it. See the picture. Okay, that is sodium hydroxide. Now, when magnesium reacts with water, the hydroxide is formed. So, magnesium hydroxide. If calcium reacts with water, calcium hydroxide is formed. So, in that way, the reactions take place and hydrogen gas is also evolved out during this process. Okay. So, this is very common that hydrogen gas is getting evolved out when metals react with water. Okay. Okay. Let us move on to the next slide. See what will happen if if we already tried that when metals react with bases, what happens? Okay, we tried aluminum foil reacting with a base, that is sodium hydroxide. When a non-metal reacts with a base, what will happen? No hydrogen gas will be evolved out, okay, in that process. So no pop sound will be produced, because there will be no formation of the hydrogen gas, no evolution of hydrogen gas. So we can differentiate metals from non-metals by doing this reaction. All right. So we can say that what are the chemical properties of, can we go to the slides before, Swapna? Again. Can you all see the presentation?
I can't see it. Yeah, I can see it now.
Yeah.
Ma'am, what all things do I have to get? I have to get aluminium foil and sodium.
You have to get aluminium foil and sodium hydroxide.
That's it?
You have to get, yeah,
Okay, I have everything.
aluminium foil, sodium hydroxide, and water, and the glasswares that you need to use. Okay.
Is this okay?
I
Should I
cannot.
use beaker?
I think your video is not on.
This is
Janvi,
okay.
is your video
Janvi,
on?
this is okay.
Yeah. So should I use a beaker or a test tube?
A test tube is okay.
Okay.
So you make the solution in the test tube and then you add the aluminium foil to it.
Okay.
Okay. So we'll move on again. Just discuss everything in a nutshell. What are the chemical properties of metals and non-metals? Okay. Can we move on to the first slide again, Swapna?
Nicola ma'am, can't you see the presentation?
No, I can't see it.
Because I almost scrolled from first to last.
No, oh, I didn't see it. Are you able to see it, everyone? Or is there
No.
some issue with my?
Yeah, now I can see it.
Yeah.
Ma'am, I think you
now
should
we can
share a window instead of sharing a screen, because every time you go back to see the class, the meet, it changes.
Okay. We can go to the chemical properties slide. Yeah, not this, the next one. Okay. So when metals react with oxygen, what happens? A metal oxide. Okay. And what is the nature of the metal oxide? What is the nature of the metal oxide? Do you all remember? Is it acidic or basic in nature? We did the first experiment, right? Can you all hear me?
Yeah, basic.
Yeah. Yeah, it's basic in nature, okay? Because we burnt what? Magnesium ribbon, okay? And we collected the ash. Then we suspended it in water and we tested it with litmus paper. The litmus paper turned blue in color. That means the metal oxides are basic in nature. What about the non-metals? When non-metals react with oxygen, non-metallic oxides are formed, which are acidic in nature. All right, this is the reaction of metals and non-metals with oxygen. We'll move on to the next slide. Not the next, after that. Yeah, next. Yeah. Okay, now what? Yeah. Now, when metals react with acids, what we studied that a salt is formed. Okay? When metals react with acids, a salt is formed and hydrogen gas is evolved during the process. But non-metals do not react with acids. The non-metals, they do not usually react with acids. All right? So metals react with acid to form a salt and hydrogen gas is evolved, but non-metals don't react with acids. Okay, we'll move on to the next. We'll show a video for this, okay? How metals react with acids and yeah. Now metals, what will happen when a metal reacts with a base? Same thing, a salt will be formed and hydrogen gas will be formed. But what about non-metals? Some non-metals react with bases, not all. Okay, every non-metal does not react with bases. A very few non-metals, they react with bases to form a salt as well as hydrogen gas. All right. Okay. We move on to the next one. So there are 4 properties that we are learning. How the metals react with oxygen. How metals and non-metals do they react with oxygen, water, acids, and bases. So these are the 4 chemical properties of metals and non-metals. Okay.
Ma'am, I'm ready with
Yeah.
everything.
Okay. I'll wait a minute. We'll just finish this. Okay. So when metals react with water, what happens? Metal hydroxides are formed. And again, the same thing, hydrogen gas is evolved out. Okay, which is common to basically all the reactions. So metal reacts with water to form the hydroxide of the metal and hydrogen gas. But what about non-metals? The non-metals don't react with water. Okay, the non-metals, they do not react with water. So non-metals, they don't react with water and they also do not react with acids. All right, next slide. Okay. Yes, Janvi, you can show the experiment.
Okay, I'll just bring it a little. So this is the.
Janvi, can you turn the test tube stand?
Like this.
One more 90-degree round.
Oh, okay, completely.
Yes.
So this is the one with the high sodium hydroxide solution. I'm just adding the foils.
Can you add a little more foil?
Okay.
Yeah.
Was your sodium hydroxide solution, is it too dilute?
I don't know. Should I make it? Could be.
You put lots of water into it?
Could be. I
I think
think
so.
there's around 1/4 is sodium hydroxide and the rest is water.
Okay, it should be a little concentrated when you're making it. It should be a little concentrated. Okay, no worries, you can try it. In the meantime, I'm going to play the video for all of y'all.